Quasi-linear general form? No, I'm asking the general form. In the definition we have written something, no? So go back to the definition and see. This is obvious, okay. I need the general format for the quasi-linear equations. Let me see. Okay. Why you put P dash 95? It's not a P dash, it's a P. Okay. Yeah, okay, fine. So it means P, X, Y, Z, capital P is a function of X, Y, Z with small p, plus Q is a function of X, Y, Z of Q, which is equal to R of X, Y, Z. So you should know the differences between all the linear as well as semi-linear, quasi-linear, then non-linear. So you have to know how to distinguish these equations. Okay. So go back to the definition and analyze it. So for generally we use this form for this solution method. It means for A, P I'm using ZX. Similarly for Q, I'm using ZY. So if you have more than one, more than two variable, you can include as well, which is equal to G. This is our capital R. But this is our capital P. This is our capital Q. Maybe P, Q, R, S, T, and capitals maybe there. Okay. So it's okay. So for this, we are taking also we have to include the cap A is a function of X, Y, Z. Similarly, this one and this one as well. So that also included. So that's what the small difference between the semi and quasi-linear equations. Okay. So check that again and see the definitions. Okay, now we have seen how to some example. Also, we have proved as well as understand the solving method. Okay, so where we use the auxiliary equations. Okay, hope you I have proved already, so I'm not gonna go again. So if you have the quasi-linear equation in this form, the auxiliary equations in this form. After that, from that we will arrive our solution of G of our solution is this arbitrary function of G of pi comma chi, which is equal to 0, where pi is a function of X comma Y, which is equal to C1. Similarly, chi is a function of X comma Y, which is equal to C2. Here we have taken only ZX and ZY. Therefore, we have the pi also only two variable, chi also two variable. We are taking as a constant C1 and C2, arbitrary constants. Okay, then we can include it in here. So this is what the solutions. Okay, so we have proved this one. So also we have understood how to take the auxiliary equations. What is dx over capital P, dy over capital Q, dz over R. So similarly in these equations, our taken equation is azx plus bzy, which is equal to G. So we know this is our capital P, this is our capital Q, this is our capital R. So when you're substituting our auxiliary equation in this form, okay? So hope you have understood everything. So I will go back to the questions today. Okay, let's use this and let's see how it is using. So where this, it is known as the Lagrangian method. Okay. So Lagrange's method for partial differential equation, which says if an equation of the form, this equation we called as a Lagrange equation. Okay. Capital P, P plus capital Q, Q, which is equal to R. So what this equation in the form of? What's this equations actually? This is our quasi-linear equations, isn't it? Okay, so if it's so, this things, it says if it's a quasi-linear form of Lagrangian, we can use our Lagrangian method to solve this. Okay, use the Lagrange type partial differential equations. For example, let me give some example for this question. Okay, the examples coming anyway, so we can let's see first of all the working rule. Okay, so there are some 4 steps. We can find out the whatever we have studied in a theorem is the steps has been divided from the theorem. Okay, first of all, transform the given linear equation. They may give in a here and there. So first of all, you have to transform the equation of first order in this standard form. Okay, so first of all, whatever they have given, say sometimes they may give zy here minus r, which is equal to b z x, something like that. They may give in a not in a order. So you have to, first of all, you have to make it as a order. So this notes going in some order, so you don't need to follow this one. When you are writing, you just write 1 2 like that. Okay, so we can keep like that. So this will be 2, this will be 2 like that. Okay, so first of all, you have to transform the given linear equation in the form of capital PP plus QQ, which is equal to R. This take as a equation number 1. Then write down the Lagrange's auxiliary equations of this one, namely, so what is our Lagrange's auxiliary equation? As we know, dx over capital P, which is equal to dy over capital Q, which is equal to dz over R. So take that as a second equation. So far we have done step 1 and step 2. Next step you have to take as solve this auxiliary equation number 2 by using the well-known methods. So there are some methods we can see different types. So there we can use different our earlier knowledges. Okay, we are not gonna study any new thing here. We already know how to solve this. So we're gonna use our earlier knowledges to find our answer. There you can find one equation pi xyz which is equal to C1 like a arbitrary constant. Okay, again chi xyz is equal to C2 and other solutions, because we have see 1 2 3 equations, 3 are equated. Okay, so you can compare, let's say for example dx over pn dy over q. If I taken these two, I may have, let's say, my pi. Okay, now I think you may get my idea. So how to solve these two? Any idea? Give me a we have studied already the elementary differential equation. We already we are studying ODE as well. So you may have some knowledge as well. Can you tell me if you have, let's say, if I take these two, what will be how I can get the xy? Let's say dx over p, which is equal to dy over q. So what is the knowledge you have to solve this one? Can you tell me in a word? So the answer, let's say pi is equal to something is equal to C1. So how you can get it? Okay, let me see. Only 42 students are here. Where's the others? 41, 42 only here. So all others are absent. If you are not in the whole 3 lectures, we are cutting our lecture 3 times, isn't it? So 1 hour like that, 40 minutes like that, 3 times we will cut. So you should be on all these 3 lectures. Otherwise it will count as a absent. Okay, you can't be in the half lecture. You can't be in the quarter lecture. Okay, so keep it in the mind. Okay, so yeah, one of the person answers. Where's the others? What is the idea of getting the answer? Pi is equal to C1. C1 is maybe any independent arbitrary solutions. arbitrary constant. Similarly, you can take these two. You can say chi is equal to C2. Okay, what is the idea behind to solve this one? Why nobody answering? Only one has answered. That is correct. Okay, let me ask the people. 009, can you answer me? How to solve this one? If you have dx, forget about p. Anyway, dx equal to dy. How to solve to get C1? It is a differential equation to get the originality. What is the idea?